413. The design and migration of services. Which of the following is true about the characteristics of a simultaneous system migration? We have four options. The first option, option A, is an application connecting the new and the old system is necessary. B, the new and the old system will run in parallel until a certain point of time where the system will switch onto the new system. C, the effect from trouble caused during the migration to the system is huge. And D, running costs occur when two systems operate in parallel to each other. In order to answer this question, we'll first of all talk about what actually is system migration. And that's the first question that we want to answer. A service design and system migration involves the planning of a new replacement system or a modification to the existing system. So it's about planning a replacement or about modifying the current system that you have. It proceeds by following the plan to the design and development of this information system and then migrating the actual operational environment from old to new. So we have some stages. We have the planning and the designing, we have to develop the information system, and then you have to carry it out. You have to migrate the actual operational environment from old to new. Migration can be from a mainframe computer to more open systems. The motivation for this can be the cost savings. So the cost savings is primarily a very important reason or motivation for migration. Now we'll go on to look at the different types of system migration. How does system migration actually get carried out? For system migrations, there are two broad methods. So we'll discuss each of them in turn. The first method that we'll talk about is called the phased system migration. It's also known as the sequential system migration. The old system in this method is replaced by the new system in stages based on units such as a specific base or part of the operation. Employing the phased system migration method can limit the range of the damage in the event of an error during the system migration. So it's about limiting the damage that you have when you have an error in the system migration. However, factors such as the necessity to connect the old system to the new and the costs involved in running the two systems in parallel possibly increases the overall cost. So the key word I suppose here is involved in running the two systems in parallel. So that's the kind of migration we have for phased system migration. The other kind of system migration we have is called simultaneous system migration. In this method, the system as a whole is replaced. So replace the entire system. Since there is no need to operate both the new and the old system simultaneously, because it doesn't make sense, because the old system and the new system are going to be totally different because they are replaced as a whole, you don't need to operate both at the same time. The cost of this kind of system migration is low. At any one point you only have one system. However, when the amount of data involved in the system migration is high, the burden of the workload increases accordingly. So if you have a large amount of data, then the burden of the workload increases considerably. In the event of trouble during the process of system migration, one single error could potentially affect the entire system. So it poses a kind of fragility to the operation. If you have even just one tiny error, it could potentially affect the entire system. So although the cost overall tends to be low, you do have some risk in your migration period. So in order to illustrate the differences between the costs and the risks of migration in each of these methods, we have a table here. In the phased system migration, you have a period where there is an overlap of the two systems. Now the cost of migration in this case is high because you need to maintain two parallel systems in operation. So it is expensive. However, the risk during this migration period is considerably lower. So you have a small risk, but it costs some money. In the simultaneous system migration system, you have a low cost of migration because you never have more than one process being operated. However, that comes at a price. The price is a large risk. If you have any single error during your process, it could fault the entire system as a whole. So although it has a low cost, it has a high risk during migration. So it's all about the trade-off. It's all about the trade-off between cost and risk. You may have a low cost, but that will come at the price of a high risk, and vice versa. A high cost, but it means you have less risk. So you have to choose between the two. So to come back to the original question, the question asks, which of the following statements is true about the characteristics of a simultaneous system migration? So that's the second system migration that we talked about. Option A says an application connecting the new and the old system is necessary. Well, we in fact learned from the previous slides that this is a description of the phased system migration. Option B says the new and the old system will run in parallel, we have the keyword parallel, until a certain point of time where the system will switch onto the new system. Again, this is a description of the phased system migration. Option C says the effect from the trouble caused during the migration to the new system is huge. This is absolutely true about the simultaneous system migration. We learnt that although the costs are lower in the simultaneous system migration, if you have even a small error, that could fault the entire system. And so this description is fitting of a simultaneous system migration. So this would be the option that we'd choose. Just to complete the picture, let's have a look at option D. Running costs occur when the two systems operate in parallel to each other. And of course, we're talking about parallel operation, so that is again an example of a description about the phased system migration. So, as we saw, the answer is C. And we found that A, B and D are all descriptions about the phased system migration.